Consider an optical medium where refractive index varies linearly with height. That is, n of y is equal to n of 0 plus ky, where k is a positive constant and y is the height above the ground level. Here positive number n0 is the refractive index at the ground level. The refractive index at height h varies with temperature at that point as ny minus 1 into ty equal to constant. Consider a ray propagating in a plane in the medium which is horizontal at the ground level, that is at a grazing angle, and makes an angle theta with the horizontal at height h, as shown in the figure. Use a small angle approximation, that is, keep only terms up to and including quadratic order in all trigonometric functions. Select the correct options. A. The temperature at height h is greater than the temperature at ground level. Angle theta is equal to root 2 into 1 minus n0 upon nh. C. For n0 equal to 1.001 and k equal to 1 into 10 raised to negative 4 per meter, angle theta at height h 1 meter above the ground level is root 1 by 5, and angle theta is equal to root 2 into 1 minus 1 upon nh into 1 minus th upon t0. And this is the graph that they have given us. Okay, this is the graph. This is the x-axis. This is the y-axis. Okay, and that's the optical medium. The ray is going to propagate in the medium. Okay, so the ray is propagating in the medium, and it is shown to be entering like this. Okay, the ray is going to enter in that direction. So we can say that the angle of incidence is 90 degrees. Right, the angle of incidence is 90 degrees because the normal at that point is this y-axis. Okay. Now, when it is going to emerge, let us say the medium ends there. Okay, need not end there, but we will consider this particular case. So what will be the normal here? The normal here will be this one. Okay, the normal there will be that one. So if we draw a tangent, okay, if we draw the tangent to the curve at that particular point, okay, if we draw tangent to the curve at that particular point, the angle of refraction will be 90 degrees minus theta. Correct? The angle of refraction will be 90 degrees minus theta. And if you look at options B, C and D, everywhere they ask for theta. Okay, everywhere they ask for theta. So while we will apply Snell's law, but we will be happy with not the angle made by the ray with the normal to the surface, but the angle made by the ray with the surface. We usually don't consider it, but this time we have to consider that. Okay, also look at option A. Option A says temperature at height h is greater than the temperature at the ground. Okay, so let us start with that option first. What is the connection between temperature and refractive index? Ny minus 1 into dy equal to constant. Correct? So that's the relation that they have given us. Now look, because k is positive, okay, because k is positive and obviously n0 will also be positive, we can say that nh, refractive index at height h, which is given by n0 plus kh, will definitely be greater than n0. Okay, so we have got the inequality nh greater than n0, right? And look, because this is an optical medium other than vacuum, the smallest of the refractive index of it will definitely be greater than 1. So we can happily subtract 1 from the inequalities all sides and still get positive numbers. Okay, still get positive numbers, and that pretty much answers the question. Okay, if nh minus 1 is greater than n0 minus 1, it means c upon ty is greater, okay, c upon ty is greater than c upon t0. So if we take t of y, it has to be less than t of 0, right? Temperature at height h is greater? No, it is not greater, it is smaller. So option A is not right. Okay, option A is not right. Now let us come to options B, C and D. Take care. In order to find the angle theta, okay, we have no other option but to apply Snell's law. But we have to apply Snell's law in its differential form. Now what is meant by differential form? Okay, Snell's law in differential form. Look, the problem is the refractive index varies continuously. Right? It is not a constant, neither it is varying discretely. Okay? Look, can refractive index vary discontinuously or discretely? The answer is yes. Suppose you have a glass here, okay, of refractive index n1. Then let us say you have water here, refractive index n2. Then let us say you have some other material which is transparent, let's say n3. So here the refractive index is varying discretely. Okay, here the refractive index varies discretely, but that's not the case here. Okay, so if it is varying discretely, what we would do is we would consider Snell's law at this interface and at this interface, right? But we have to basically do that for every small, I would say, slice of the medium under current case, because n is varying continuously. Okay, so here we will say n sin theta equal to constant. Okay, n sin theta equal to constant. This could be angle of incidence or angle of diffraction, right? Because see, look, the original Snell's law is what? Sin I upon sin r is equal to n2 by n1. So basically, if a ray is propagating from medium 1, the angle of incidence there multiplied by sine of the angle of incidence multiplied by the absolute refractive index of that medium will be, if r is the angle of refraction in medium 2, then sine of r into n2 will be a constant. So that's exactly what is meant here. Okay, n into sine theta is equal to constant. Let us now first put the parameter with which n is varying. N is varying with h, right? N is varying with h. What is the formula? ny is equal to n0 plus ky. Okay, ny is equal to n0 plus ky. Let us use it now for n. Okay, n0 plus ky sin theta equal to constant. Now we have to differentiate both sides with respect to a variable which we do not specify. Okay, which we do not specify, and clearly we need to apply the product rule. Okay, so let's take the derivative of the first, which will be k dy sin theta as it is, plus first term as it is n0 plus ky. Okay, n0 plus ky. Derivative of sin theta is cos theta d theta. Constant's derivative is 0. Okay, constant's derivative is 0. Now what we need to do is we need to adjust the terms. Okay, we need to adjust the terms. Okay, so let us make that adjustment. First of all, let us send that n0 plus ky cos theta d theta term to other side. So it will acquire a negative sign there. n0 plus ky cos theta d theta, and here what will it be? It will be k dy sin theta. Okay, k dy sin theta. Now we are yet to integrate. Okay, we are yet to integrate. So let us bring that negative. Okay, let's bring that negative sign here. Let's write k dy there. n0 plus ky here, and on this side it would be cot theta d theta. Okay, on this side it will be cot theta d theta. Okay. Now look, in this case, in this particular derivation, what is theta? Theta refers to angle of incidence or angle of refraction. Correct? Here theta refers to angle of incidence or angle of refraction. But as we noted earlier in our examples, that is however not true. Okay, rather the cases that we considered at incidence and at the emergence, angle of incidence is 90 degrees there, and angle of refraction is 90 degrees minus theta. Correct? So what changes do I need to make now here? Okay, what changes do I need to make? Look, the theta that we are using here, okay, the theta that we are using here is actually the complement of what we have here. Okay, theta there that we are using is actually complement of this theta. Okay, so what will change now? What changes do I need to make? The theta that I have written in the red color, okay, the theta that I have highlighted in the red color needs to be replaced by which angle? 90 minus theta. Okay, did you get this step? Yes or no? Okay, you got it. Okay, so look, suppose we do it right here. Okay, suppose we do it right here. For theta we make the change 90 minus theta for the angle of the angle which the ray makes with the normal. Then what would change here? It would become cos theta. Okay, it would become cos theta, right? Then okay, let's just do it here. Now I'm going to put it as cos theta after I made that change, and now we can apply the rule again. I'm not doing it right here. Okay, we'll see whether it changes anything. Okay, I would have easily done that tan theta there, tan theta, and then d theta will change to negative d theta, but let's see. Okay, let's do it first in this way. Again differentiate, so k dy cos theta, okay, k dy cos theta plus n0 plus ky n0 plus ky into negative sin theta d theta equal to 0. Shift that negative term to the other side, so it will become positive. So it will be n0 plus ky into sin theta d theta. Bring n0 plus ky here. Okay. Bring sin theta there, cos theta there, send it there, so it will be tan theta d theta. Okay. Now let us compare the two expressions that we have obtained. Okay. Let us compare the two expressions that we have obtained. Here we had the negative sign with cot, Okay, and in this case we don't have that negative sign here. There is no negative sign here, and there is tan theta here. Now look, are these two expressions equivalent or equations equivalent? The answer is yes, they are equivalent. How? Look, when you make the change theta to 90 minus theta, first thing that will happen is cot theta will become cot 90 degrees or pi by 2 minus theta, and you know that is tan theta. Okay, so that matches well with this. But what will happen to d theta? Pi by 2 that is 0, and then it will be negative d theta, right? So this negative sign here, okay, now let me use green color there. This negative sign here takes care of this negative sign, and therefore both the expressions are equivalent. Have you understood this now? Okay, so that negative sign is taken care of by the substituted theta. Alright, so this is a differential equation in the variable separable form, and now our job is to integrate this. Okay, now our job is to integrate this. How are we going to integrate it? It's better to keep it in the definite integral form. Okay, so here we will write y equal to 0 to y equal to h. Okay, y equal to 0 to y equal to h. Now look, look, angle of incidence is 90 degrees. So in our notations, what is theta? Theta is 0. The angle made by the ray with the normal. Okay, angle with a surface, sorry, angle with surface. And here it will be just theta. Okay, not 90 minus theta, theta. So at y equal to 0, the angle is 0. Okay, which angle again? Theta, angle with surface, not normal. Okay, angle with surface and not normal. And this theta is what we want. We are looking for that, right? Now we can integrate this. Okay, on integrating, k into 1 upon k ln, no need to write mod, it's already guaranteed that it's positive, n0 plus ky with limits 0 to h is equal to integral of theta is ln sec, okay, with limits 0 and theta. Okay, with limits 0 and theta. Kk is going to get cancelled. Okay, kk will get cancelled, and what will we get now? Ln. Now allow me to use the allow me to skip the step. Upper limit will be n0 plus kh, and in the denominator it will just be n0. Okay, in the denominator it will just be n0, and here it will just be ln sec theta. Now why it will just be ln sec theta and why not that other term? Because we know sec 0 is 1 and ln 1 is 0. Okay. Now the way you simplify after this, okay, is very important. Okay, the way you simplify it after this is very important. We can get rid of the log now because we know all terms are positive. So we can write it as nh upon n0 is equal to sec theta. Okay, nh upon n0 is equal to sec theta. Why? Again, go to the relation that they gave us. Ny is equal to n0 plus ky. Okay, ny is equal to n0 plus ky. So nh is equal to n0 plus kh. So what will be cos theta? Reciprocal of that. And also use the Maclaurin expansion for cos theta. Okay, what is it? Actually cos theta is 1 minus theta squared by 2 factorial plus theta raised to 4 by 4 factorial minus theta raised to 6 by 6 factorial and so on. But we have to truncate it, we have to stop it after the second degree term. So theta squared by 2. So n0 by nh equals 1 minus theta squared by 2 bring theta squared by 2 to LHS, send n0 upon nh to RHS, it will become negative, bring 2 here and take root. Okay, bring 2 here and then take root. So theta will be 2, well, root of 2 into 1 minus n0 by nh. And it matches, does it match with option B? Yes, it does match with option B. n0 by nh. Okay, n0 by nh. So that completes the validity of option B. Okay, did you get it now? Yes. Okay, now let us go to option C. Let's do it on calculator now. Okay, let's go to option C. They're saying for n0 equal to 1.001 and k equal to 1 into 10 raised to negative 4 per meter, theta at height h 1 meter above the ground level is equal to root 1 upon 5. Because this formula is correct, we can use it to find theta. Okay, 2 into bracket 1 minus n0 1.001 upon nh n0 plus k into, okay, k into what? H, but h is again 1 meter, right? Okay, what is the formula? n0 plus ky. Okay, and according to the answer it should be root 1 upon 5. Let us check it here. Root of 2 into bracket 1 minus fraction 1.001 in the denominator 1.001 plus 1 into 10 raised to negative 4. Okay, so what is that answer? That is 0.014. Okay, that is 0.014. Let's not take the root. Okay, that is 2 into 10 raised to negative 4. That is 2 into 10 raised to negative 4. And is it equal to 1 upon 5? No, that's definitely not equal to 0.2. Why is it not equal to 0.2? Because it is missing so many terms, so many powers of 10. Right? We may write it as 2 into 10 raised to negative 4. Okay, but will it be equal to 0.2? No, because 0.2 is 2 into 10 raised to negative 1. Okay, so there is a difference of orders of magnitude equal to 3. Right? So C is not right. Okay, C is not right. Now let's go to option D. Now we know, while starting with option D, we know the relation that we proved in B is going to be useful. So let us first write that. That relation is 2 into 1 minus n0 by nh. Okay, this relation is from B. And we also know another relation between refractive index and temperature that is given in the problem. Ny minus 1 into Ty equal to constant. Right? Ny minus 1 into Ty equal to constant. So we have to now somehow make use of that also. This relation as well to get to option D. Let's see if we can get it, or do we get something else? Okay. First of all, let's go to the relation and put the values. So nh minus 1 into th equals n0 minus 1 into t0. Okay, so what we have done is we have substituted y as h, and then we have substituted y as 0. Okay, let's try to separate n0. So we will get th minus t0 here. Okay, this will be n0 minus 1, right? Th by t0, and here it will be nh minus 1. Okay, so what did I do? I basically kept n0 minus 1 to right side, brought t0 to left side, and then let us bring that 1 to LHS. Okay, so we will basically get 1 plus nh minus 1 into th by t0 as n0. Okay, and then we have to substitute that n0 there. We have to substitute that n0 there. Okay, this one. Then now let's see if we get it. Therefore theta is equal to root of 2 into 1 minus n0 is 1 plus bracket nh minus 1 into th by t0 upon, okay, 1 plus nh minus 1 into, yeah, okay, upon nh. Okay, so we have successfully managed to eliminate n0. Okay, we have successfully managed to eliminate n0. Now let us see if the terms get simplified. Therefore theta is equal to root of 2 into bracket, let's take the LCM, so nh minus 1 minus bracket again nh minus 1, right? Look, firstly we need to take this one with nh, so that is nh, then this is 1, that will become minus 1 because of this negative sign, then nh minus 1 into dh minus t0, that will also become negative. Okay, nh minus 1 into th by t0, and in the denominator again we will have nh. Okay, now what we can do is we can take nh minus 1 common from the numerator. Okay, we can take nh minus 1 common from the numerator, this term and this one. Okay, so in the second term we will have 1 from nh minus 1, first one, and from the second we will have th minus t0 subtracted from 1. And then if we take that nh with nh minus 1, it will be 1 minus 1 upon nh into 1 minus th by t0. Does it match with option D? Yes, it does match with option D. Okay, so option D is also